Hi everyone, I'm Darren. So I'm here to talk to you today about these little green boxes that I've been putting together. So we want to get these set up, right? It's pretty straightforward, it's plug and play, there's no driver faff. The key thing to do straight away is, if you can see this, we have bind. Behind this hole, if I crack this one open, this one's got a lot of hot glue in it, so you have to excuse me. You probably can't really see it either. But this top corner one, oh come on camera. This top corner chip here is a receiver, so this is the Frsky version. This also has another board on the flip side. This is for the serial inversion, which is needed in order to talk to our microprocessor board, which is Arduino based. So basically you need a Poiki device. Any old thing, skinny enough to get in the hole is good. You should feel a fairly decent tactile kind of click if you get it just right. So you want to hold that down, and then when you've got it held down, plug in USB. Sorted. So once you've done that, you should get normally a red flashing light. So it does vary a little bit between models, and I don't have all of the transmitters out there, so I can't fully test everything. So I'll leave that one down to you. You probably have a better idea if you own the hardware. So with the Frsky one, at least, you'll get a red flashing light. It's a steady flash, at which point you can then go onto your transmitter, and you'll want to go into the menu, scroll all the way through your model settings to find the bind button, press that, listen for the beep, 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 beep noise, and then your box will flash slightly differently. That basically means that it worked. You can stop pressing the bind button at this point. You can press it again to make the beeping stop, and then unplug the USB, turn off your transmitter, plug the USB back in, turn your transmitter back on. So just go through a whole cycle of turning both off, turn both back on. And then once that's up, you should get a green flashing light. And then you're good pretty much. So I mean, that is for the Frsky. The others will vary a little bit with the various color LEDs. Like I said, this one has the bind button, and the RX light is also on the front as well. The key important note with the Frsky ones is, if I've sent you a non-EU or an EU and your transmitter is the opposite, then you will get both a red and a green light up steady when you reconnect your controller. That's bad. It means you're running the wrong firmware. So we'll need to reflash that. It is just a standard Frsky XM receiver, so the non-dual antenna one, because we're 2 feet from our PCs, it doesn't matter too much. And I've got somewhere here an example of the other ones. So I've got one of these ones and one of these ones. Okay, so this is, I don't know if you can see this, AFHDS2A. So that is your Flysky one. You'll notice on the front of this that you have your bind and you have your PC. So your power light just shows that you've got power from your PC going to the unit. The PC light will only light up once you've bound and the receiver is sending a signal. So this essentially is to show communication between the receiver and your PC. But note that this has no RX light, because the RX light is on the back in this tiny hole. So bear that one in mind. Just moved around a little bit. And then the DSMX version is slightly different again. That looks like this. It's quite a bit larger. There's not very many fairly affordable kind of DSMX receivers that do PPM. So the bind hole at the top is where you would put your bind plug, as per normal. The bind plug comes with the unit as well. You've still got the standard RX light, and you have the PC, and you have your power light as well. So to kind of show them all side by side, so you can kind of get a gauge at the size. This is your Frsky, in the middle is your Flysky, and then DSMX is on the end there. So I have to keep looking up so I can see what I'm showing. And that's pretty much that. So then we can go into the actual setting up of a simulator. So this is going to run through setting up your transmitter receiver box on a Windows PC. So with Mac and with Linux, you don't really need to calibrate, and to be honest, you don't massively need to on Windows either, but it's pretty trivial to do so. So we'll run through. The first thing that you need to do is to open up Control Panel. You can do that by going through to the Windows key, typing Control and choosing the option. Then you're going to want to go into Devices and Printers. So this on Windows 10 is pretty similar on Windows 7 as well. And you'll see that in the device and printers menu, we have this SparkFun Pro Micro. That's just the name of the Arduino chip that we use here. So you're going to want to right click on that, go into there, and then hit on Properties. And once you're in there, you can hit the Settings tab and Calibrate. And that will go through the device calibration wizard. So as you can see, leave the D-pad centered, just leave all your sticks centered, including the throttle. Then go through and twiddle all of the sticks to make sure that you cover the full axis. So you'll find that one of the sticks will cover kind of one axis, and then another stick might cover two. It's a bit flaky, so the way that it maps the sticks. So once you've done that one anyway, hit next, find the stick that it thinks is the Z-axis, roll through that one, hit next, go through the same process with a Z rotation, and then next again. Slider is normally assigned to a switch. So, and then your calibration is complete. Hit apply, and OK, and OK again. And that is your calibration complete. So, the next step will be to set up the actual, say, Velocidrone we'll go through here. Okay, so now in Velocidrone, we're going to go into the settings menu and into USB controller setup. And then from here, we're going to want to go and click on the first box. So we've got this throttle box. We're going to click on that. Well, firstly, zero the stick. So put it in the middle, probably the best to start with. Wait for the timer to finish, and then move the axis, and it will automatically assign it based on what you want to be your throttle. Do the same with roll. So again, wait for the timer. Now move it again, and you'll see that the craft in the top right corner as well moves with it. Do the same with pitch. And the craft moves again. Same with yaw. Okay. So I've also got a switch, I think. So I like to assign that to probably either the race start toggle or the reset. So same again, except I don't think I've set it up, so that one didn't work, but you get the gist. Okay, so that gives us the basic setup for our sticks and the input assignment. So the next is to calibrate those so that our alignment with the range is evenly distributed across the whole thing. So you hit calibrate for axis 0, which we've got assigned to throttle, set it into the middle, wait for the timer to finish, and then move it across the whole range. So all the way up, all the way down, and then back to the middle again. And then you'll notice that you get the white arrow and the yellow arrow. So this is what it's effectively going to put into the simulator versus what our stick command is at the time. So you can see that the actual offset, that middle red section, is slightly offset. So going on to axis 1 for the roll. So you do the same process again. You hit the calibrate, you center your stick, wait for the timer, move it all the way across. And that's it. So you will notice as well when I'm doing this left and right, the quad in the top right is moving along with my input. So if it's doing the opposite of what you're expecting, just hit the invert button on this screen as well. So I'm just running through this, doing it for axis 2, which is our pitch. And then I also need to do it for axis 5 for our yaw in a second. And we just calibrate again as usual. So wait for the timer, leave your stick centered, full deflection, and job done. Just make sure the direction's right on that top right when you're moving it around. So we go back again. Let's go into a single player. I think that's an appropriate name for a quad. And then we wait for it to load. And let's give it a go. Seems to fly. Doesn't mean I'm any good. I'm still pretty ropey on Sims. I'm much better in real life. Honest. Can I make it through the swing? Oh, Okay, and that's about it. So this, obviously, this is a very similar process for the other simulators. I actually found Velocidrone to be one of the most complex to set up because it doesn't give you a very interactive wizard guide. Things like liftoff have a much more intuitive setup, so it's much a similar process, but a lot more automated. So, okay, well, enjoy your adapters and happy flying.